Hello, everyone. Today we're gonna show our project. Our project is about cognitive load and skeleton performance. Next. Okay. We thought about nurturing tasking, and we thinking the lifting task is one of the most physical demanding tasks of the nurses because they have to lift patient, move like heavy machine, and that make produce very muscular musculoskeletal disorder, shoulder injuries, back pain, and sprain. Adding poor cognitive conditions, so a slow reaction time, vigilance, and making decision could affect more than the performance on the nurses. There is some consequences like for the company and for the hospital, high cost in employers from the absentees, loss in production, and workers compensation costs, and also musculoskeletal disorder for workers. One of the solutions that the research give us is upper and lower limb skeletons. Is a potential solution for mitigate this lifting. And also, if with ergonomic support, we can handle how the physics task is. And there is research who demonstrate that the efficiency in reducing physical strain with the skeleton. Our objective is investigate the interplay of cognitive load and motor performance while the people is using exoskeletons. Our motivation is in exploring the interplay of cognitive and physical demands. That means like how we can approach this physiological and biomechanical indicator. Also, personal difference between like each task and how is the workers have behavior in the environment. Also, holistic understand of imaging workload. Day to day, there is action and response, shift work, poor management roster that make more poor the performance, and also mental health issue could affect this how the body reaction to this sleep. And the last one is ensuring seamless integration of a skeleton in the work environment. We wanna analyze the job lifting in our experiment to lead conclusion about how the people could improve the performance with a skeleton, exoskeleton.
Our experiment assesses the use of exoskeletons in two conditions. First, without any cognitive load, and second, with the presence of cognitive load. Our first hypothesis is that the task performance decreases with the presence of cognitive load during the task. Our second hypothesis is that the participant will perceive a higher workload and higher exertion during the cognitive load conditions. Our final hypothesis is that the EMG activations remain constant throughout the two conditions because the physical forces and the rigid body kinematics remain the same in both the conditions. Now we'll describe the task. So our task has three components. The first is the mind, which is where the participants are required to memorize a 10-digit alphanumeric serial number. The second aspect is the motor, which is they are doing the box reference task. The third aspect is the machine, which is represented by exoskeleton. The participants on arrival provide their verbal consent. After they consent to participate in the study, we take a background questionnaire in order to assess their previous experience with the exoskeletons and their work background. After completing the background survey, we perform task familiarization, where we teach the participants on how to perform the lifts and how to do the task from start to end. We complete 3 trials in this practice condition and ask the participant if they need more practice. If they don't need any further practice, we don the exoskeletons on the participants and put on the bioinstrumentation. The task is shown in the picture here. The participant is required to pick up a box which is about 10 kgs from the ground and place it on the table. The green color represents our first condition, where they are doing the task without any cognitive loading. Now we modify the task a little bit. And instead of just doing the task, they also have to remember the 10-digit alphanumeric key, which is placed beneath the box. Once they complete their box placement on the table, they are required to type in that 10-digit alphanumeric code into the computer. The only way for them to succeed is to remember the number throughout their motion from the left location to the right location. These 2 conditions, represented by red and green color, are counterbalanced. At the end of each condition, the participants fill out NASA TLX questionnaire in order to assess their perceived workload. They also fill out their perceived exertion.
For our study, we are going to recruit a total of 10 participants with 5 male and 5 female. Participation in this experiment is fully voluntary, and participants will not receive any monetary benefit from this study. Verbal consent will be taken from all the experiment before the study begins. For our measurement part, we are going to capture the complete mind-motor-machine interaction. We will be using subjective, performance, physiological, and behavior measure. For subjective measure, we are going to first use NASA TLX. This will help us to measure perceived mental workload. NASA TLX has been shown to effectively capture the perceived workload in a number of other studies assessing exoskeleton use. Secondly, we are going to use Boggs rating of perceived exertion scale to measure perceived exertion. For our performance measure, we have identified 2 performance metrics. First is efficiency. This will be the average amount of time taken to move the box from location A to location B. Second is accuracy. This will basically help to capture how accurate is the alignment of the placed box within the target location and the correctness of the serial number input in the system by the participant. For physiological measure, we are going to use EMG. This technique is used to measure and record the electrical activity produced by muscle during contraction and relaxation. Fundamentally, it measures the electrical signals the muscle fibers generate when they contract. The EMG measure can provide insights into several aspects of the muscle activity, such as muscle activation, muscle contraction timing, muscle strength, among others. For the purpose of this project, we will be focusing on muscle activation. Finally, we are going to measure, our behavioral measure will be the characterization of the pose of the participants while performing the lifting task. We are going to record the task videos and then extract the 3D human pose from them using Video Pose 3D software. The raw data obtained from the EMG sensors and the task videos will be analyzed using Python, and the process subjective and the subjective data will then be exported to in R for statistical analysis. Thank you. If you have any question, do reach us out.